All right, guys, those of you at home, you're going to take your test on Monday, but today we're going to extend this idea of inequalities. So yesterday, your basic introduction, and we deal with inequalities kind of like we deal with equations. There's a few things I want to talk about in terms of what to watch for. First of all, just keeping in mind that when we see an inequality, when we see something like x is less than 3, what we're saying is we want to represent all of the values that are less than 3. And we can't list all of those numbers on the number line, so we visually show all of those numbers. And again, that's why we have this, number line. We want to show all the values that are less than 3. And again, we talked about that yesterday. It would be an open circle with an arrow this way. That means that anything on the number line that's being covered by that line that you just drew is part of the what we call the solution set of that inequality. I go down to negative 12, it's covered by that part of the arrow that you drew, it's part of the solution set. Anything up here not covered by that line is not part of the solution set. So keep that phrase in mind, okay? That number 3, that division between what's included and what's excluded, has a name that's called the boundary value. And what we do is we decide, is that boundary value included or excluded? Okay, so a couple of phrases to keep in mind. We see these boundary values oftentimes included in something like a multiple choice question. Which of these, A, B, C, or D, is a solution or is in the solution set to this inequality? So we could solve, or we could substitute them in and check. Is negative 3 greater than negative 8 plus 4? So what I usually do is I put a little question mark there. I'm going to ask myself, is that true or false? Is negative 3 greater than, well, that's negative 4. That is not true. Oh, yes, it is true. Sorry. Negative 3 is greater than negative 4, which means that negative 8 is included in the solution set here. How about negative 7? Is negative 3 greater than negative 7 plus 4? Well, here's where we get that inclusive versus exclusive will be important. That's negative 3 is greater than negative 3. Is that true? No, it's not. If this said greater than or equal to, then yes, we would also include the negative 7. And what we do is we just test these points in that inequality and see what's true and what's not true. This is not true that negative 3 is greater than negative 2. It's not true that negative 3 is greater than negative 1. So we rule out B, C, and D, and our only solution here would be negative 8. So watch these. The inclusive versus the exclusive is what we need to look at. Here's another example. Here's one with decimals. Now we could solve these by adding the 0.2 to both sides. N is less than or equal to 0.6. Well, let's see. 0.5 is less than or equal to 0.6, but also 0.6 is less than or equal to 0.6. That boundary value in this case is included because of that little line underneath the inequality. So this one has two solutions from that multiple choice list. All right, we're going to talk about a couple things you need to remember. One of them is that whenever we have one of these inequalities, I want you to write this rewrite it with the variable on the left. This says 4 is less than x, which doesn't make a whole lot of sense. 4 is less than x. It's hard to wrap our minds around. It seems like here's 4, and that's a less than sign. Seems like it should be going that way, but let me rewrite this with the variable on the left. I'm going to rewrite this as x on the left, 4 on the right. And what I notice is the arrow is pointing at the 4. It should be pointing at the 4 also when I flip that around so the variable's on the left. And now that it's written that way, the sentence makes more sense to us. This is saying x is greater than 4. This arrow should go to the right. So be aware of that. If the variable's on the left, flip it around. I'm sorry, if the variable's on the right, flip it around, put it on the right before you graph it. I'm going to insist on that because you're going to get it wrong frequently if we write it like this. Here's an equation where we have variables on both sides, and we mentioned this yesterday. Plan ahead a little bit. Now when I plan ahead, the variable ends up on the right. So what I want to do is, once I get my solution, is to now flip it around so that the variable is on the left. X is there, negative 14 is here. The arrow's pointing at the 14. It should be here as well. Okay, and then I would put my number line with my closed circle arrow this way. So again, solve it, and you could solve it any way you want to, but just make sure at the end, right before you graph, that the variable is on the left. All right, there's one more thing you need to keep in mind with inequalities, and this is the big one. It's always going to be true in Algebra 1, in Geometry, in Algebra 2, in Pre-Calculus, Calculus. Anything you do, it's really easy. You just have to remember to do it. I can tell you 500 times, but at some point in the year, it's going to click in your minds, and you have to remember to do this on your own without being prompted. It's not hard. Let me walk you through why we do it. All right, here's an example of why we have to pay close attention to this. And we'll work through the process here. So this says negative x is less than 5. And we remember there's a negative 1 in front of that x. So in order to solve for x, I would divide by negative 1. And it looks like I've got x is less than negative 5. So here's negative 5, that boundary value. And it looks like I should be going this way with my arrow. But let me check some of these values here. If x is negative 5, well, it's not inclusive, so I don't want to try negative 5. Let me try a number like the next one down would be negative 6. And I'm going to go back to that original inequality. Is it true that the opposite of negative 6 is less than 5? Is that true? Well, the opposite of negative 6 would be 6 is less than 5. That's not true. Wait a minute. Something happened there. That is not included in my inequality. In fact, I could say the same thing about every single point down here. When I draw that arrow and have that boundary value, I'm saying that every point is going to act the same way in that inequality. The opposite of negative 8 is not less than 5. So I'm going to solve this in a slightly different way. I'm going to take that inequality, and I want that coefficient of x to be positive. I'm going to add x to both sides. I would get 0 is less than 5 plus x. And then I could subtract 5 from both sides. I would get negative 5 is less than x. And then again, I'm going to turn it around. This is saying x is greater than negative 5. The reality is that the points that solve this inequality are all the ones that are greater than negative 5. If I check a value like negative 4, it is true that the opposite of negative 4 is less than 5. Or the opposite of 0 is less than 5. Or the opposite of 27 is less than 5. Every number up here, when I take its opposite, it will be less than 5. Strange little thing happened there. So here's what you need to remember. When we're solving inequalities, if you divide or multiply both sides of an inequality by a negative number, you absolutely have to reverse the direction of that inequality sign. It's not a hard rule to remember. You just got to pull it out whenever you use it. Reverse the direction. And if we had more time together, I would explain in multiple different ways, but we do not. So we're just going to memorize a rule, okay? Again, if we divide or multiply both sides of an inequality by a negative number, we have to flip that inequality so that it goes the other direction. If it was less than, it's now greater than. If it was greater than, it's now less than. Let's look at these two similar examples, but slightly different. If I'm solving this equation or this inequality on the left, I would subtract 4 from both sides. So I treat it just like an equation right up until this very last step. Negative 3x is less than or equal to 15. Now when I solve, I'm dividing both sides by a negative 3. Our answer is going to be x is greater than or equal to negative 5. So because the physical act, the verb that I did right there was to divide by a negative number, I flip the inequality so that it now goes the opposite direction. Now I want to contrast that with the one on the right here. I would add 4 to both sides. I get 3x is less than or equal to negative 15. Now the verb that I'm doing here, the action shot here, is that I'm dividing by a positive 3. I'm dividing both sides by a positive 3. So it's not the fact that this one has a negative in it or that I'm dividing a number with a negative. It's the fact that I'm dividing by a negative on this side. That means I've flipped the inequality. In this case, I'm dividing both sides by a positive number. That inequality stays the same direction. Okay, so two slightly different things. What we look at is, am I dividing in that last step by a positive or a negative number? If it's negative, I flip the inequality. If it's positive, I do not. I'll just leave you with these couple last little problems. If I'm solving this one, I would subtract 5 from both sides, and I would have negative a is less than 1, and then divide by negative 1, and a would become greater than negative 1. In this equation, or this inequality, I have choices here. I always say plan ahead, and if I plan ahead, I might choose to add the 2a to both sides, which is a good idea, because then my variable's coefficient is positive. However, it puts the variable on the left. Another option for me would be to subtract the 4a from both sides. And that's okay as well. The variable's now on the left. The difference is that I have to remember now that I'm going to divide by a negative number at the end. So that's your choice. I'm not going to finish this problem. We're running out of time. Your choice, it doesn't matter. Just keep your head in the game when you're doing this. That's really the only thing you need to remember. Put the variable on the left, and when you divide or multiply both sides by a negative, flip that inequality around. And that's it. All right, we're going to practice some of these on Delta Math, and then we're done for the week. All right, and I'll see you Monday for your test. Bye-bye.